In this video, we're going to look at simultaneous equations. Now, simultaneous equations are two equations, well, usually two equations, and they have the same two unknowns and are simultaneous because they are solved together. So let's say we had the two linear equations, y equals 2x plus 1 and y equals x plus 7. Now, these two equations are a pair of simultaneous equations because they have the same two unknowns, y and x. Okay. So what we can do with this is we can combine the two equations and we can solve for y and solve for x. Now there are two ways to solve a simultaneous equation. We can either use a method called substitution, or you can use elimination. Substitution is probably the easiest when you first learn it, so it's probably a lot easier than elimination. But once you get used to elimination, it will become much easier and much more efficient than substitution in most cases. So let's look at substitution first. So the method of substitution involves three steps. First step is to solve one equation for one of the variables. So step 1, solve one equation for a variable. Now this solve is not quite solve, but it's like rearranging the equation. So what we want to do is that we want to express an equation so it's in the form of y equals something, let's say square, or x equals triangle. Yep. So let's try rearranging the first equation here, y equals 2x plus 1. Now luckily it's already rearranged for us, so we get y equals 2x plus 1. But if we want to make it in terms of x, that would be x equals, so since y equals 2x plus 1, we move 1 to the other side, so it becomes y minus 1 is 2x, and we get x equals y minus 1 over 2. So x is equal to y minus 1 on 2. Now our second step is to substitute this expression into the other equation and solve. So now we have the value of y and x for the first equation. We can use either of these. We can use y or x, and let's try using y. And we can substitute y equals 2x plus 1 into this equation and solve for x. So step 2, we have y equals x plus 7. So this is our second equation, this one here. And from our first equation, we know that y is equal to 2x plus 1. So if y is equal to 2x plus 1, we can put 2x plus 1 here. So we want to replace y with 2x plus 1, and the right hand side stays the same, x plus 7. Now we just rearrange, so move x to the left, that's x equals 6. Okay, so we know that the x value for these two simultaneous equations is 6. Now our final step, step 3, is to resubstitute the value we got from step 2, so x equals 6, back into the original equation to find y. Okay, so we want to substitute x equals 6 into either the first or second equation. Okay, let's substitute it into the first equation. So y equals 2x plus 1. So here's y equals 2x plus 1. if I substitute x equals 6, we get 2 times 6, 12 plus 1, so y is 13. Okay, easy. If you want to substitute it into the second equation, you can do it. You can do that too. So y equals x plus 7. X is 6, so we get 6 plus 7, that's 13. We end up with the same answer as before. So now our final step is to write a therefore statement. Therefore, the solution to the two simultaneous equations are x equals 6 and y equals 13. So x equals 6 and y equals 13 satisfies both of these equations when you substitute these values into the equation. Let's try one more example. Let's say we had 3x plus 1, y equals, and y equals negative 2x plus 3. Okay, so first step, rearrange one of the equations. Well, in this case, it's already rearranged for us. So y equals 3x plus 1. Step 2, Step 2, substitute y equals 3x plus 1 into y equals negative 2x plus 3. So if y is equal to 3x plus 1, we can substitute 3x plus 1 into here. So we get 3x plus 1 equals negative 2x plus 3. That's 5x equals 2. So x is equal to 2 on 5. Now our third step is to re-substitute x equals 2 on 5 into any of these equations. So let's substitute it into the second equation. So y equals negative 2 times 2 on 5 plus 3. That's negative 4 on 5 plus 3. So plus 3 is equal to 15 on 5. Okay, so add the fractions. That'll be 11 on 5. So that is y. So the solution to our simultaneous equations are x equals 2 on 5 and y equals 11 on 5. So that's substitution. Now we'll have a look at elimination. So elimination is it's slightly more confusing. So the first step in elimination is to multiply each equation by a suitable number so that the two equations have the same leading coefficient. Okay. Let's say we had two equations, ax plus b, y equals, and y equals alpha x plus beta. Okay, a, b, and alpha, beta are just variables. So I'm just doing a generalized model instead of using numbers. So what I mean by make the leading coefficients the same is that we want to multiply both of these, or sometimes one, but usually both, by some number, the whole equation by some number, so that a equals alpha. So we want this number to equal this number. So let's do it. Let's say we had y equals 2x plus 2 and y equals 3x plus 1. Now you can see how the coefficients of x is different for the two equations. So that's 2 and that's 3. We want to make that into the same number by multiplying the whole fraction by some constant, which is a number. So to do that, we need to find the lowest common multiple of 2 and 3. Okay, so the lowest common multiple of 2 and 3 is 6, because 2 times 3 is 6. So how do we go from 2 to 6? We times 3. Okay. So we times the first equation by 3. Okay, for the second one, how do we go from 3 to 6? We times 2. So let's call this equation 1, and let's call it equation 2. So what we have to do is do 1 times 3 and 2 times 2. If we do that, we get 3y is equal to 6x plus 6. So we times 3 to all the terms in the equation, including y. So our second equation would be 2y equals 6x plus 2. Okay, and our second step is to subtract or add the second equation from the first. And by doing so, we can get rid of one of the variables from our equations. What I mean by that is we can't solve for both x and y at the same time. So we want to get rid of one of the variables from our equation. It can be either x or y. And to do that, we need to subtract or add the equations together. So in this case, what happens if we add the two equations together? Then we would get 5y equals 12x plus 8. Now, you see how we still have y and x. So this is not going to work. So what we need to do is we need to subtract the equations. If we subtract the equations, we get y equals, now 6x minus 6x, they cancel out, so that's 0. And 6 minus 2 is 4. So we get y equals 4. And that's our y value for the simultaneous equation. And our third step is the same as substitution. It's just resubstituting the value into the original equation. So let's use the second equation. 2y equals 6x plus 2. Substitute y equals 4. So we get 8 equals 6x plus 2. 6 equals 6x. And x equals 1. So our solution to our simultaneous equation is x equals 1 and y equals 4. Let's try another example. Let's say we had y equals 2x plus 1 and y equals 6x minus 3. So our first step is to make the leading coefficients the same. So we need to find the lowest common multiple of 2 and 6. In this case, the LCM of 2 and 6 is 6, because 2 times 3 is 6 and 6 times 1 is 6. So if we call this equation 1 and that equation 2, we need to times 3 to equation 1 to get the leading coefficient equal to 6, because 2 times 3 is 6. And to the second one, we don't have to do anything because our coefficient is already 6. So equation 1 times 3 is 3y equals 6x plus 3. And our equation 2 is the same, y equals 6x minus 3. Okay. Second step, we either add or subtract the equations to eliminate one of the variables. Now we can see straight away that if we subtract the equations, the 6's will cancel out, right? So let's subtract it. 3y minus y is 2y. 6x minus 6x is 0, and 3 minus 3 is 6. Because a negative and a negative makes a positive. Okay, so that's not right. The equation sign should be here. So 2y equals 6. So y should equal 6 divided by 2, which is 3. Now our final step is to resubstitute y equals 3 into one of the equations. It doesn't matter whether you choose this, 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 or this. You can just choose any of them. Let's go with the simplest one. So let's go with equation 1. Substitute y equals 3 into y equals 2x plus 1. So 3 is equal to 2x plus 1. 2x is equal to 3 minus 1, which is 2, and x equals 1. Hence, our solution to our simultaneous equation is x equals 1 and y equals 3.